All right, in statistics today, we're looking at standard deviation. Okay? Standard deviation is used in a population, and when we use it in a population, we use this Greek letter called sigma. This is a lowercase sigma. In a sample, standard deviation is just S. Okay? They're calculated the same way except one slight difference. I'll explain that to you in just a minute. We have what's called variance, which variance, you find it before you find standard deviation, but variance is sigma squared or S squared if you're talking about a sample. Let's get it on the screen here. Okay? But there's two different notations for standard deviation. We use sigma for standard deviation if we're talking about a population. We use S for standard deviation if we're talking about a sample. What standard deviation is how spread out numbers are. Now, if you look at, say you have some test scores and the average test score is 80. Okay, most people are going to score 80. So like right down the center here is 80. All right, as we go over one standard deviation, say standard deviation is 5, this would be 85. And this would be 90. That's 2 standard deviations over. Back this way, this would be 75, and this would be 70, and so forth. But it's how spread out they are. Well, you might have another test that has the same 80, but they're spread out more, and so one standard deviation over might be 90, and then another standard deviation would be 100. And so the numbers are spread out more. It has a higher standard deviation. So the standard deviation tells how spread out our numbers are. Okay, so let's find the standard deviation. Here's a list of numbers here. We'll work on this. So we got 9, 18, 30, 36, and 42. So first thing we want to do is just make sure they're in order, and they are. So we got 9, 18, 30, 36, and 42. The first thing we got to do is we got to add these up. So we find the sum. Now this is a capital sigma right here, which means the sum. So the sum of these right here, let's see, that's going to be 27, 57, 87, 93, 95, 135. Okay. Now divide that by 5, and I'm going to have, let's see, 27. So in this is X bar, this is a population. All right, so mu is, what did I say, 27. Mu is 27. Okay. So now what I do to find the standard deviation, I take each one of these numbers, and I'm going to go 9 minus 27, and I'm going to square it. I'm going to take 18 minus 27 and square it. I'm going to do 30 minus 27 and square it. 36 and 42. I'm going to take each one of these numbers, I'm going to subtract 27 from it, and I'm going to square it. All right, so if you get my calculator here, it's real simple. Punch this in. I just go 9 minus 27. Well, I said it was simple. 9 minus 27, enter, square it, enter. This is 324. I do this one. 18 minus 27, enter, square, enter. That's 81. I do 30 minus 27, enter, squared, enter. That's 9. 36 minus 27, enter, square, enter. That's 81. And then 42 minus 27, enter, square, enter. 225. Okay? And then once I do all them, I get the sum of those. All right, so I add these up. So let's add them up here. 324 plus 81 plus 9 plus 81 plus 225, and I get 720. Okay. All right, so in this population, we had 5. So I divide this by 5. And 720 divided by 5, I think it's 144. Let's check, make sure. Yep, 144. So when I divide them by 5, Okay, I get 144, and that is sigma squared. This is my variance. Okay, and now sigma, which is my standard deviation, is the square root of that, which is 12. So I got 144 is my variance, and 12 is my standard deviation. Let's look at the answers out here. Yep, look here. 144 and 12. We're in good shape. Okay. All right, so on this one, this is a sample this time. You see, it's a sample. Okay. Which is a little bit different. We'll go through that. So let's write them in order. So we got a 4, we got a 14, we've got a let's see, 29. Is 29 next? No, there's 22. 22, and I got two 29s. All right, then I got a 32, a 33, and then I got a 35. I got a 49 and a 58. Let's see here, 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. So we got them all. So there they are. Okay, and we wrote it up there. All right, first thing I do is I add them all up so I can find the mean. So I add these up. 4 plus 14 plus 22 plus 29 times 2 plus 32 plus 33 plus 35 plus 49 plus 58, and I get 305. All right, I divide it by 10 to find my average, and now my average, and of course, mean is the average, and this is a sample, so it means it's X bar equals 30.5. All right, there's my mean. Nope, you don't on the screen here. X bar is 30.5. And so now what I do is I take each one of these, 4 minus 30.5, and I square it. I'll do 14 minus 30.5, and I square it. And I'm not going to write all these down, but I'm just going to come over here, 1, 2, 3. Okay. I'm going to punch them in here. So I got 4 minus 30.5, enter, square, enter. That's 702.25. Okay. Then I got 14 minus 30.5, enter, square, enter. 272.25. 22 minus 30.5, enter, square, enter. 72.25. 29 minus 30.5, enter, square, enter. 2.25, and this is the same thing because it's the same number. 32 minus 30.5, enter, square, enter. 2.25 there as well. 33 minus 30.5, enter, square, enter. That's 6.25. All right, 35 minus 30.5, enter, square, enter. 20.25. 49 minus 30.5, enter, square, enter. And again, all I'm doing is I'm taking each one minus the mean, and I'm squaring it. So this last one, 58 minus the mean, enter, and I square it, and I get 756.25. And so I got to find the sum of all them. Okay. And so what I notice here, see how these are all 0.25s? What I'm going to do is I'm going to do 0.25 here. Get this cleared off. And maybe I can move this. Well, it's not wanting to get into the screen very good. Here we go. Let's try that. I'm going to do 0.25 times 10. Since there's 10 of those 2.25s, and now I won't have to worry about that. I'll just punch in the whole numbers. So plus 702 plus 272 plus 72 plus 2 plus 2 plus 2 plus 6 plus 20 plus 342 plus 756. When I do that, I get, oh crap, I had an error. Okay. There. 2178.5. I recommend doing this a couple times. I've already done this previous, and that's what I got both times. So I'm good. I know I'm good. All right, well, here's the difference now. Like I said, this is a sample, which is different than a population. So that means what the difference is right here. Once I get this numbers added up, I divide by 1 less. I divide by 9. I don't divide by 10. Okay? Because what we have here is we've got 9 degrees of freedom. We've got 9 degrees of freedom, which means this. These numbers, you know, this is a sample. And so of these 10 numbers, well, these numbers can be anything, these first 9, but once these first 9 are in, that 10th one is locked in. It has to be just one certain value to get this 305. And so the first 9 have degrees of freedom, but the 10th one doesn't. So we divide this by 9 in a sample. We don't do that on population. The population we divide by 10. All right, so we divide by 9. All right, so I divide this by 9, and I get 242.06. All right, this is my standard deviation squared, which is my variance. This is a variance. Okay, and if I take the square root of that, I get 15.56. Now let's see what it wants us to round. Okay. It says round to one place. So I guess this would be 242.1. I don't know why that was 06, but this one's 15.6. I got 15.56. If I round it one place, it'd be 15.6. But that's how you do it. We'll do one more, okay? Number 9 here. Okay. All right, the following data represents the flight time in minutes of a random sample of 6 flights from Las Vegas, Nevada to Newark, New Jersey, from Las Vegas, Nevada to Newark, New Jersey on United Airlines. So here's 1, 2, 3, 4, 5, 6 different flights with their times, their random times. All right, well, let's put these in order. So we got, let's see here, 257s first. Okay, then I got 260. Then I got 266 and 267. Then I got 270, and then I got 282. There you go. There's my 6 flights in order. Okay, now the first thing says compute the range. The range is just when you take the highest one minus the lowest one. So that's real simple. Let's just knock that out. 282 minus 257, that's 25. So the range is 25. So it fluctuates 25. Range also tells dispersion, how numbers are dispersed. But it's not as specialized as what standard deviation is. All right, so now it says find the sample standard deviation. All right, so what we're gonna do is we gotta find the mean of those. So here's my sigma. To find the mean of those, let's add them up here. So 257 plus 260 plus 266 plus 267 plus 270 plus 282, and I got 1602. It's probably good to do them twice. Just make sure 257 plus 260 plus 266 plus 267 plus 270 plus 282, 1602. All right, well, there's 6 of them, so you divide by 6. And that's 267. So that's my X bar. 267. That's my mean. Okay. Now, since my mean's 267, I'm going to take each one of these, 257 minus 267, and I'm going to square it. I'm going to do that for each one of these. All right, so let's start off here. 257 minus 267, that's 10, and I squared it's 100. Then I got 260 minus 267 equals, square equals, that's 49. Then I got 267 minus 267, which is 0, and square it, 0. Uh-oh, I skipped 266. Let's move that 0 down. I skipped 266 minus 267 equals, squared equals. That should be a 1 right there. We skip that. 270 minus 267 equals, squared equals. That's 9. Then I got 282 minus 267 equals, squared equals 225. Okay, and so I add all these up. So that's going to be 159 plus 225. I added them up, 384. Okay, I'll do that again. 100 plus 49 plus 1 plus 9 plus 225, 384. Okay, now again, this is a sample, which means since there's 6 of these, there's only 5 degrees. N minus 1 is 5. There's only 5 degrees of freedom, so I divide this by 5, which is 76.8. This is my variance, which is my S squared. And now I do the square root of that for my standard deviation. I do the square root of that, which is 8.76. All right, so let's look and see if we got this right. 25 was the range, we did it a while ago, and the standard deviation ran it to 1 decimal place. The 6 would make the 7 go up to 8, so 8.8 is right. There you go, 8.8. All right, so the main thing to remember, let me find that page I wrote earlier. Here it is. You have standard deviation for a population, which is sigma. You have standard deviation for a sample, which is S. Okay? They're computed the same way. The only difference is when you do a sample, you have N minus 1 degrees of freedom. And so when you go squaring and then add all those together, you divide by 1 less if it's a sample. Okay? Anyway, we'll talk more about that, but standard deviation, if you have any questions, just give me a shout. I'll try to help you all I can, okay? Have a good rest of the day.